Hello, I'm Yang from Intelligent Big Data Visualization Lab, Tongji University. I'll be presenting our work, ColorCook, Augmenting Color Design for Dashboarding with Domain-Associated Palettes. This work is in collaboration with Peiliu, Siji Chen, Jiang and Professor Nan Cao. Visualization dashboards as an information presentation use a tile layout of charts to support collaborative decision-making and condition monitoring. In dashboard design, color receives priority among various visual elements. It serves as both an important visual channel to encode data and a pivotal feature to communicate the characteristics of information design. However, creating dashboard colorings is challenging, as a well-designed coloring should be both effective and expressive. It is often achieved by a multi-step color workflow, including how to select a palette that best represents the idea of the content being colorized, how to assign the selected colors to the appropriate segments of charts, and how to arrive at a satisfying coloring. One potential solution to avoid being overwhelmed by hundreds of design decisions is leveraging computational color design to automate the color workflow. While recent work has shown to be helpful in designing effective visualization colorings, they have mainly focused on parts of the color workflow for independent charts. To bridge such a gap, we introduced ColorCook, a design support tool that facilitates the expressive and effective color design of multiple coordinated charts within a dashboard. Let's see a demo. Initially, a user uploads a sales dataset to the data panel. Then she selects a palette from the business category in the Color Palettes panel. She then clicks the Generate button and views the result on the canvas. She continues to add more charts to the canvas. She also explores different coloring results with the current palette by clicking the Update icon button. Also, ColorCook suggests alternative colors for the dashboard colorings. Our system was developed to address a set of design requirements we had derived from the interviews with domain experts. In the following, I'll explain each design requirement in detail. ColorCook requires a dataset of domain-associated palettes as a palette library. Users can expressively communicate the data content of the intended dashboard through color selection. To create such a dataset, we followed a three-step procedure. We first identified the common domains of dashboards by investigating existing dashboard tools. We then collected illustrations that depict scenarios of the identified domains and extracted corresponding color palettes from these designs. We also filtered and validated the dataset from three aspects, including distinctiveness, aesthetics, and specificity. The corpus of our domain-associated palettes can be accessed at the following link. To generate dashboard colorings based on a selected palette, we also followed a three-step procedure. ColorCook first extends the discrete palette to sequential or divergent palettes based on data types. Here, discrete palettes can be used to encode qualitative values, each representing a distinct category. Sequential palettes can be used to encode quantitative values, while divergent palettes can be used to encode quantitative values with a midpoint, such as 0. To ensure color consistency across multiple charts, that is, same field, same value color mapping, ColorCook then segments a dashboard and assigns the colors to the segments accordingly. Here, we define a segment as a component of a chart in a dashboard that can be color encoded, and an area as a set of segments encoding the same data field. We relate dashboard areas to data fields as their numbers are equal. An area consisting of one or more segments is assigned to the same color, while a dashboard is a collection of such areas. Also, color assignment follows established rules in visual perception regarding color harmony, discriminability, and continuity. Specifically, color harmony is produced when two or more colors seen in neighboring areas cause a placing effect. Color discriminability describes the difference in lightness between neighboring areas. Color continuity encourages adjacent areas to have similar lightness values. In terms of color suggestion, we use the color palette rating model proposed by Kate et al. To suggest harmonious colors for a given palette. First, HSV color space is explored while candidate colors are constrained to those that are essentially different from the colors in a given palette. The candidate colors are then selected by rejection sampling and added to the given palette. Last, each of the palettes is rated by the model, and the top-rated colors are recommended to users. The evaluation of ColorCook includes a crowdsourcing experiment and a user study. We first conducted a crowdsourcing experiment to examine the effectiveness of our domain-associated palettes when they are used to colorize dashboards. In the experiments, the participants were instructed to rate the dashboard colorings generated using our palettes and baseline palettes. To further understand how ColorCook is used by professionals, we then carried out a user study. In the study, the participants were tasked with using the system to create dashboard colorings for specific domains. That ends my presentation. Thank you for your attention.